Logarithm. So hopefully you guys know a common logarithm is a logarithm with base 10. A natural logarithm is a logarithm with base e. Now, you were supposed to watch the video to explain exactly what e is, but essentially if you were to graph this function, which is your compound interest formula, as you increase x, this function approaches an asymptote, and that asymptote is at e, which is a number, approximately 2.718. It is an irrational number and keeps going, and your calculator knows how to calculate it. So we use our calculator to figure that part out. Since natural logarithm is like a special logarithm, it gets its own special little notation. So instead of writing log base e over and over again, we do ln.
X? Is it ln x or ln?
Well, if you're usually it's like the natural log of something. So yeah, like ln x. So like see right there. ln x.
Shut up. What did he say?
Now, because the natural logarithm has a base e, e and natural log are inverses. So we can use e and natural log to undo each other.
Wow.
In the sense of inverse operations like we were just doing up there. And you can rewrite an exponential equation as a logarithmic equation like this.
There's like a bar under this table and it's stacked.
Logarithm.
Like this thing right here.
Are you kidding me?
I like
Natural logarithm.
like
Logarithm natural.
It's great. That actually really hurt. I hit my knee.
This is right here the definition of a natural logarithm.
Why? Okay, so should I write? Yeah.
Mm.
Probably should if you were
I think I'm gonna go for it. LNY. I don't like these like inverse things because I always put the little guys in the wrong places.
Wait, is that ln or in?
L. Yeah. Lots of people start writing L. Remember, this is a logarithm. It's an L.
Can I write a cursive L if I want to?
I actually do that because
People
think it's an I. Yeah.
Yep.
I'll go back later.
Would you like to see grading this?
Alright, so let's solve some stuff and things. Here we have the natural log of x minus 3 squared equals 4. Now there's a few ways we can solve this question. I'm going to solve one way. To start, instead of having this squared, I'm actually going to pull it out in front so that it looks like 2.
You're undoing it?
Yeah, I'm undoing it. I can leave it there, but when I leave it there, I might wind up with extraneous solutions. If I pull it out, I'll get rid of the extraneous solutions. I'll only get the right answer. So by pulling it in front, I can divide by it and get rid of it completely.
Wow. Wait, so you moved it, divided it? Okay.
So I moved it in front, so you're using the power property, and then I just divided by 2. Now,
I feel like this should
so
be
when it's in the front, it's multiplying, but when you combine it together,
it looks like
it's
one
a
N.
power.
I hate this.
It's weird.
to undo my natural logarithm, I'm going to use an e.
Just use 10.
Okay.
My favorite thing you ever said was
E and natural log are inverses, so they cancel, and over here I get e squared, which is going to require a calculator to estimate. And then I can just add 3.
So if we like, so we can just like put in e squared, right?
Mhm.
And it will give it to us.
Yeah. So this is your exact answer, and then you can approximate it using a calculator.
I'm gonna do it. 905609889.
You just had.
I think I did it really good because I have an answer and it's good.
I'm gonna add 1,
It's my grandpa.
Oh.
No, because white people can vote.
and then I'm gonna move the 3 in front of the natural logarithm. And then because I moved the 3 there, I'm gonna divide by 3.
Oh my god, Bishop, I'm doing so good with this. You should be so proud of me. I'm doing logarithms all by
And now I
myself.
use e.
Yes. Oh, I didn't use e.
What'd you use?
I didn't use anything.
Oh.
I-
Well then.
Well.
You need e to get rid of the natural log.
I forgot to use e, guys. I literally
Darn
just
it, I'm
finished
like completely wrong.
Look at what I did. I literally just like finished.
You need e to get rid of the natural log. Then we can add 4
Oh my god. Wait.
and divide everything by 3.
I wrote the question wrong. Am I retarded?
I literally just. How did you?
All right, so this is our exact
You wanna know what I
answer.
got?
And people really
E
just
to
use
the
the word
negative
retarded now.
4/3
Is
plus
something
four
over?
arbitrary. What? How? I could not
All
tell
right,
you.
we get approximately 3.796.
I like didn't even acknowledge that the ln was there. I just kind of
We
got
just
rid
kept
of it.
going.
My
Just
answer was like
pretend
3
he
minus
wasn't there.
4 over 2 or something, and then my answer was x equals 2.
Well, that's cheating.
You know what? I think it looked really good until you.
Now, these have E in them, and we need to kill the E to solve.
No, don't kill the E.
We're going to murder the E. So,
Murder the E's?
step 1,
Oh my god.
I'm going to subtract 3.
Yes.
No, we're gonna murder the Europeans.
What? I still never understand.
We're trying to get the X by itself. We're going to get rid of everything that we can.
Oh,
Now we'll divide by 4.
right.
And then here we get stuck because we have this E.
Can you
And
divide by 4 and the little 4 at the top divide 2?
no.
That would
If you put an E there, will it cancel itself out?
No, but we can put the inverse of E, which is the
ln.
natural log.
Hey.
Okay.
Ew.
Bam. 4 minus X equals the natural log of 5.
Let me know why my X turned into a 3 really quickly.
What?
And then I can subtract 4.
I have no idea.
Divide by -1.
Remember, do not combine this 4 with this 5 because this is not a 5. This
Can I
is a
put
natural
4?
log of
Yeah.
5. So don't combine them. And then you're going to divide by -1 to get rid of the negative sign in front of the X. So you'll
Doesn't that
get,
just like make the 4 positive.
yeah, and it makes the natural log negative.
What? Equals negative.
So that is your approximate answer,
I
or
love
your
it.
exact
How do you
answer. Your
Huh.
approximate answer is 2.391. Using a calculator. I
I
just
did it in my head.
type this in.
Duh.
Don't do it in your head. Do practice using the calculator so I know that you're
Hold on,
capable
let
of
me
doing
can I
it.
use a calculator real quick just so
Mia invested $6,000 into a retirement account that earned 7% interest compounded continuously, which means you need to use this formula. When will Mia's money double? So, first, $6,000. What is that representing?
P. The P.
Just
Okay.
makes it so cool.
7% we want as a decimal, so that is our
0.07.
rate. Yep. And then we don't know what T is.
Wait, I have a question.
Yeah.
Why don't you put the 6,000 in front of the T?
Here?
Yeah.
Because this is a different
That's
variable.
different.
What variable is this?
So 12,000.
12.
This is 12,000 because this is when will her money double.
Plug it into my calculator. Is that what we do right now? We just plug it in, right?
No.
Why?
We have to solve an equation.
Why? Why is my phone dumb?
Yeah.
I will never understand.
So,
Alright,
do we
so the
divide
fir-
both sides by 6?
First thing you're going to do is divide both sides by 6,000.
So, it'd be 2.
So, 2.
So,
So we just learned how to solve this. How do we get rid of E?
ln.
I-N.
Ln.
L-N.
Just so you know.
So natural log of 2 equals 0.07 t, because the natural log and the E will cancel.
Did I do this right?
And then,
Divide by 0.07.
yep.
Doing great, fellas.
Okay, and
Good
then
job.
basically you need the calculator for the rest.
My whole LN is always cursive now. I don't
Yeah,
know.
once you started doing that, I was like, definitely doing that.
Well, because I can't write the
Sure.
I where it looks like an I and I'll get confused.
So I caught 9.902. So we're going to say Mia will double her money
Is this right?
in about 10 years.
3 days. Oh.
I put F instead of T. I'm dumb.
Yeah, you are.
Thanks.
It's fine. Variable's a variable.
Yeah, you know what?
That's
I
not-
feel like he would have
That's
understood.
not too long of a time. Like
That's because the interest rate's 7%. That's
Oh.
completely unrealistic.
What?
7% is a
Nah.
lot of interest.
When I was little,
In China, it's
they used to have these things called savings bonds. and you can buy them. You could buy them from banks. They're government savings bonds. You bought one for $50, and then in 18 years it would double and turn into $100. So when I was little, when I was born, that was like what people bought as gifts. Like, hey, happy birthday, Merry Christmas. Yeah.
In 18 years, you'll be rich.
So when I went to college, I had all these savings bonds that were worth hundreds of dollars, and that's what I went to college with. Savings bonds. I went to go buy a savings bond for my nephews a few years ago, and they like don't exist because the interest rate is so low that they would never double like in your lifetime. That's how bad the economy is.
The interest in China is pretty good.
That's how much things have changed. And I'm not that old, I'm only 29. The amount of carbon-14. Carbon-14 is an isotope of carbon remaining in organic matter, can be used to determine the age of an object. So, for example, right now, you are alive. And so if I was to analyze the amount of carbon-14 in your body, you would have all of the carbon-14, 100% carbon-14.
You sure?
When you die, it slowly decays, okay?
What is that called? I forget.
Carbon-14, an
decay.
isotope.
The half-life.
Carbon dating.
Radioactive
Yeah,
element.
something like
Yes,
that.
carbon
Carbon
dating.
dating?
Yes,
Oh,
this is
like
carbon dating. All right. This is the abbreviation for carbon-14. So C14, content of an ancient piece of wood. So you have to remember that wood is also a living thing.
What?
So they found an old piece of wood, and it said it was found to have 3/10 of that in living trees. So that means that about 70% of the carbon-14 has decayed. So 3/10 or 0.3. So it means it's pretty old if it only has 3/10 remaining. Does that make sense? If it had 100% when it was alive, like a living tree, and then it died, it has now decayed to 3/10 of that in living trees. We're gonna carbon date and try to see how old this piece of wood is. To do that, we have to first know the half-life of carbon-14 is 5,730 years.
So we're looking for 20%. Wow.
So this piece right here is given to us so that we can figure out what the rate is. Okay? This is a two-part question. So with part one, we are going to find the decay rate. And then with part two, we are going to find age of the wood. Half-life means that in 5,730 years, the wood will have 50% of its carbon-14 in it. Now that doesn't mean that in double that time, the carbon-14 is gone. That's not what that means. But it does mean that it has half of its life in an amount of time of 5,730 years. And so we're going to use that to solve for R. We're making P, which is our principal, so we're using this formula to just specify here. P, our principal, or our original amount, is 1, or 100%, aka the living tree.
That's our living tree.
Our living tree. It will be half of its life in 5,730 years, so we're plugging that into years, and we're solving for R. So, again, living tree, that's what the 1 represents, 100%. Half is half-life, or 50%. And then this is my time, and this is my R, and I just used the same formula that we just used. To solve this, we don't really need the 1, so if you want, you can go ahead and erase that. Because it doesn't matter. 1 times anything is itself. And then we need to solve for the exponent, which is up here. So how do we get rid of E?
ln.
So we're going to find the natural log of both sides. And we get the natural log of 1/2 equals 5,730 times R. Then we can divide to get R. Now, it's going to give this number to you in scientific notation. And I'm going to show you how to take it out.
Oh,
We're
okay.
literally doing chemistry right now.
Chemistry is just applied math. To take this out of scientific notation, so this is what it looks like on the calculator. It has like a capital E. You see that? That just means times 10 to the negative 4. So all you're going to do is you're going to take the decimal place and move it to the left 4. So 1, 2, 3, 4. So this is going to be 1, 2, 3 zeros, and then 1, 2, 1, approximately. And it's negative because it's a decay rate.
Is this gonna be on our quiz?
It's going to be on your test.
This question?
Wait, when's the test?
This is like a hard question.
Next week.
It's gonna be bonus, don't worry.
Oh yes, next week.
It's on
Is it
Monday.
It's not going to be a bonus.
It's on Monday.
Don't spread that rumor. All right.
No, I'm spreading it.
Will they be
Once
bonus?
we find R, we can now answer the question. So let's go back to what we know about this question. So, how old is the piece of wood? What we know in our formula is we now know the rate. So I'm going to plug that in.
Good lord.
What we don't know is how old the piece of wood is. So that means we're solving for T.
I thought that T was time.
T is time. That's how many years old it is.
You good, Brittany?
How much carbon 14 was there when the wood was alive? The original amount.
100, so 1.
So 1. And then how much does it have now?
70%.
3 tenths. It has 3 tenths.
Okay. Yes.
So LN.
Or you could also put like 0.3 if you want. It doesn't matter. Okay?
0.0001.
So 3 tenths or 0.3, and then we're going to solve similar to how we solved the last one. Yeah, we're going to use a natural log.
LN 0.3
Actual
equals
beaver
LN. I meant that's
So equals 0.000121T. And then you'll divide by that.
0.3, right? Oh,
By
divide
this big thing. 0.000121.
Yes, so.
So this is
I'm
ugly.
guessing.
Don't worry, guys. I'm
8,000
gonna find it right now. Control divide. Control LN 0.3
Oh.
negative
I got it.
0.000121. It's 99. Hey.
9,950-ish years old. So you have to remember, we rounded our rate, so this isn't going to be super accurate. The less we round our rate to, the better. If we don't round the rate at all, then obviously it'll be more accurate, but we have to round at some point. So this is an estimate,
Yes, so.
but it's
That's an old tree.
Well,
this is
every
how they
tree
know
is
when the
not-
dinosaurs lived.
Oh god.
They
Oh
did
my
the same
God.
thing with dinosaur bones.
Being a paleontologist
What
doesn't
if
sound too fun if you have to do that.
Wait, really?
What
It's
if
just
dinosaurs
this?
were just ants?
Gotta- Yeah. So if in 2000 it started off at $12,000, and then in 2007 it rose to $15,000. We want to know what rate will allow us to do this in a 7-year period.
So it's 5 over 4.
So you're going to divide by 12,000 and you get 5 over 4. Is that what you're saying?
Yeah.
Are you sure? Yeah. Divide by 3. Yeah. So 5 over 4.
And then you do LN.
So the natural log of 5 over 4 equals 7r.
Wait, R7.
It really
7r.
does not make a difference.
Doesn't matter. Yeah.
R7.
Interesting thing, it's R7.
And you divide by 7, right?
And then you divide by 7. And so that's going to give you the growth rate. So this one's growing exponentially, not decaying.
So the rate. would
So
be-
it's going to be a positive number. I'm rounding to 3 like non-zero decimal places for these.
Bless your
Number
face.
six,
the last one.
Thank you very much.
So it is
Not sure.
0.031877650.
Wait, yeah?
Yes.
Okay, now you're going to use that rate to answer the question. So it says If it increases
so that would be
exponentially.
7
continuously.
or 11 years.
How many years have passed? Not since 2007, since the original 18. So that's your time. Don't use 2007 because your model is based on
The original.
the original.
So then it would just be equal to.
So 12,000 e to the 0.0319 times 18 power.
12 e 0.039 again. Are you sure that the p shouldn't be? No.
RP is 12,000. That's when this whole story began.
I got 2,100.
2,000.
So you literally just plug that
Can't be small. Yeah. Like this. I got $21,308.51.
Oh, I forgot a 0.
Oh, that'll do it.
Yep.
That's why I put commas, because we'll do questions with like lots of zeros and it trips me up.
That's the problem.
Now again, this is assuming that it's going to grow using this model. That's like a very bold assumption,
Nah.
but a fair one possibly.
Is that how they like calculate?
They use stuff like this to calculate like the federal debt.
What's
Is
the
this the
federal
hardest?
debt?
You think this is the hardest chapter?
Of this semester? Probably.
This?
Oh, I definitely am. I hate this.
I just don't like logarithms.
What's the federal
Unless you don't
debt
like
right now?
graphing.
Me? No, I'm fine with graphing.
What's the federal?
Okay, so I think we did talk about how like ibuprofen is something that exponentially decays in your body.
I'll forever have ibuprofen in my system.
So an adult takes 600 milligrams of ibuprofen. It says after 1 hour it has decayed by, not 2, but by 29%. Assuming it is decaying continuously. So we're just that just means assuming we're following this model. How much ibuprofen will remain after 7 hours? This is a 2-part question, okay?
Find the rate. No.
Yeah, part 1, we're going to find the rate.
So would it be 0.29 is equal to?
Well, it says it decayed by 29%. So if something decays by
71%.
right.
0.71.
So if it decays by 29%, then you got to like subtract it from 100. Sorry, I should put 100, not 1. Right? So it's now at 71%.
See, this is the stuff that like I would never know to do that.
And it did that in 1 hour. You're not supposed to know. I'm supposed to teach you.
I know, it's just like I hate word problems.
Also, I'm using decimals. I'm using like 0.17 and 1 for 100, but you could actually use like 71 and 100. Like that.
No.
I'm just saying. You
Wait,
can also
so this
use
is
that.
So would you
Natural
do
log
the
0.71.
LM?
Yeah, so we don't really need this one because 1 times anything is itself, so we'll just take the natural log of both sides. We get the natural log of 0.71 is equal to r, because 1 r, because 1 hour, and then that's pretty much it. So you just calculate from there.
LN 71.
0.71.
0.71. Negative, right?
Yeah,
0.34249.
so I'll do 0.342.
And that's T, right?
That's your rate.
That's the first part.
That's R.
So that's the first part, find rate.
I thought the rate was 0.71.
No, that's the.
No. That's how much it decreased to after an hour.
I hate those.
What the heck is round? But you know what's funny? We might actually have to.
So
apply this
part-
in real life.
Part 2, we're gonna answer the question. So it says how much is left after 7 hours. So you guys know ibuprofen. How much is going to be left?
0.
Well, not 0, but
Negative.
not a lot in
So-
7 hours because you're supposed to take it every 4 to
Like
6.
0 point something.
I don't know. We'll find
Will
out.
there ever be zero
What is
actually
that
like flow from the body?
It's still there.
No, 'cause it's exponential.
It's still there, but it's not affecting you
What's
anymore because
Advil?
it's so minuscule.
Wait, will there still be? So ibuprofen never goes away.
Because it's exponential. You always have 0.0.
It's gonna keep decaying to a point where it's so small that it's essentially gone.
But it's not actually gone.
Yeah, it'll be
you
gone.
take drugs,
Theoretically.
and
Because
drugs will
your
always
body
be in
gets
your
rid of
system.
things,
It'll always
It's
be in your
just
heart
very
rate.
small.
Well, your body gets rid
Wait,
of
can we
things.
just finish this? Because I'm actually kind of confused.
Okay.
So we have 7 hours, so that's our time. That we know our rate is this guy right here. We know that we started with 600 milligrams. Okay, so e to the 7 times this rate 0.342 or negative 0.342, and we're finding the amount after 7 hours. So you should have p of 7 equals 600 milligrams times e to the 7 times negative 0.342 power.
Can you just plug that in?
You're plugging in the right side.
0. It gave me 0.
Wow, so smart.
And it has a little yellow yield sign or something.
You're plugging in just the right side.
That is what I did.
Are you sure?
I'm so positive.
I got a 54.
How possible?
Yeah, you should get.
Oh, I put negative 342. That'll
Oh
do
yeah,
it.
that'll do it.
That'll do
It's
it.
an insane rate.
That'll
She
do
goes.
it.
I got 0.
6.8396.
Okay, so
105 is just this.
first, it says the amount of consumed caffeine decreases by 12% in 1 hour. So if it decreased by 12%, that means we're at 88% of what we were when we started. So if we started with 100% caffeine, we are now at 88% caffeine.
That's right.
RT. T is 1 hour. That's one way to do it. The other way to do it is to actually calculate what 12% less than 120 milligrams is. So that would be 120 milligrams minus 12% of 120 milligrams. And you'd get 105.6. And that's what you would put here. Because this is 12% less than 120.
Wait.
Now,
I
if
thought we
you
were
do
finding
it,
the rate.
yeah, we are. I'm saying there's 2 ways to do this.
Oh.
If you do it this way and you actually calculate 12% less than 120, your first step would be to divide by
I
120.
put 50 on the left.
That's
the
too
second
soon.
one.
Too soon.
No. Okay.
We're first using the first 2 sentences to figure out what the rate is. You can't figure out the answer until you know the rate. So we
Yeah.
can't use this yet.
I got 0.1278.
It's negative 0.1278.
So we're going to solve this. So what I was trying to say, if you do it this way, when you divide by 120, you wind up getting this anyway. So it
It's
just
like
skips a
longer way to
step.
get there.
It is. So you're going to take the natural log of 0.88, and that's going to give you your rate. So
Yeah, I got negative.
this is negative.
0.12783.
All right, so I'm doing 3 decimal
Go
places.
for it.
Okay, now once you find your rate, you can answer the second part. So it says, how long, so we're finding t, before the effects wear off, or basically decrease to 50 milligrams. So we want to know when 120 milligrams will decrease to 50 milligrams, and it's going to do so with this rate.
Yeah.
So divide by 120.
I think what I did was I multiplied everything together first.
Hmm.
I multiplied 120e, all of that.
Yeah, natural log.
Can I not do that? Or do I have to divide first?
Divided by
You have to divide first.
1.13.
And then divide by the rate.
I got it.
And then use your calculator for the rest.
6.8396.
I got 2.112.
Hmm.
That's because you got 12 over 5, and that's what I got in the first place, but I did wrong.
6.8.
396.
4.
What? Oh.
I don't know, I just
Yeah, I
rounded
have a
sooner.
What I did was.
So
Is it
we started with 120.
Yes.
We want to know when it's going to decrease to 50. So you start with 120, it's decreasing to 50. So that's why the 50 goes over here. This is after time. This is original.
Thank you.
Also, years?
It's hours, right?